Hey everyone, we prepared another Amazon interview question today. Today's question is, given a root node, check whether the given tree is a mirror tree or not. Let's understand the definition of a mirror tree. If you were to draw a line in the middle of a tree and swap all the elements on the left side with the right side, the tree should look exactly the same. Following this definition, the first tree is a mirror tree. For this tree, you just need to check this one and this node are the same. Let's look at the second tree. This is not a mirror tree because the location of the node 5 is different when comparing the left side and the right side. The third tree is a mirror tree because this node and this node are the same, and this node and this node are the same. If you were to swap all the elements on the left side with the right side, the tree would look exactly the same. Before we dive into coding, let's make sure we're on the same page with the interviewer. To be honest though, the question is pretty clear and there are not that many questions you can ask. I'll probably ask something like, how children of each node will be given? It will be given as a list of node. So I'll children nodes sorted from left to right. And the answer is yes for this case. A single node considered as a mirror tree. And the answer for this is yes as well. Let's see what kind of algorithm and data structure we can use to approach this question. For me personally, I would use queues to collect nodes to compare in the right order and compare all at the same time. Let me illustrate my point with the example I prepared right here. We need to compare nodes level by level, and in a certain order, either left to right or right to left, depending on which side of the nodes they are. If you were to draw a line in between the tree, I would collect the left side of the nodes level by level, right to left order. Then I would collect the right side of the nodes similarly level by level, but left to right order. When I construct these two queues, I would pull one out at a time and compare each node. If I find any node that does not have the same value, I'll simply confirm that the given tree is not a mirror tree. Let's fill this queue together to understand it better. What I meant was I would go through a level by levels and right to left order. And also for the right side, level by level, but here it will be left to right side. Before 1, 5, 2, 1, 4, 1, 5, 2, 1. Each values are the same, so we can confirm that this is indeed a mirror tree. Would the algorithm we discussed work for this second example as well? Let's go through it. We'll draw a line in between and collect level by level. On the right side it will be right to left, the left side it will be left to right. Before 1, 5. On the right side it will be 4, 1, 5 as well. The contents look exactly the same, but some nodes have the wrong formation. The node that has value equals to 5. Not only do we need to check node's value, but we also need to check their formation as well. So instead of storing just the value of each node, I would actually store the reference of each node and compare its value and its children. So let's change to store the reference. Circle is indicating it's a node. When we pull the first element out, it's this one and this one. So we check its value, and when we check the children sides, this one will be 1 and this one will be 2. So it is not a match, so we simply return false in this case. We're checking from top to bottom because we're going level by level. We know that one level above nodes already checked the formation, so we can assure that the current nodes that we are dealing with have the same formation. All the previous examples that we dealt with had only 2 root children. What if the root node has more than 2 children? In this case, we would have to compare its children one by one, starting from the leftmost and rightmost node, this portion and this portion. then the second rightmost and the second leftmost, and continue this until we come to the middle point. If the number of roots children is odd, we would also have to check whether the middle children itself is a mirror tree or not. So a lot of recursive calls, I would imagine. Let's see how we can translate our algorithm into code. Just create a simple node class, so it just has a value and the list of node, which is representing a children. I would start by creating a helper method called isMirror that accepts two parameters, left node and right node. It checks whether the given left node is the mirror image of the given right node. As we previously discussed, we would construct a queue for each side and compare them in order. So when we pull each node from the queue, we would compare the value and the formation of its children. Value, the formation of the children. If all nodes look the same, we'll just do a final check to make sure that each queues are empty and return true. Let's see how we can construct each queue. We would need two queues in this case. One is to iterate through the entire children of the given node iteratively, and the other queue is to collect all children sorted in the right order. We start by putting the given node in the iterating queue. In the while loop, we pull one node from the queue and insert its children in the right order. If it is coming from the left node, we would insert children from right to left, so we would have to reverse the list and insert them in the queue. Reverse. If it's coming from the right node, we would just insert all the children in the given order because the list is already sorted from left to right. The while loop will stop when we go through all the nodes of the given node. At the end, the iterating queue will be empty, and the queue will be constructed with all children nodes in the right order. The final step is to use all these helper methods and check whether the given tree is a mirror tree or not. In order to compare all the roots children nodes, one by one, starting from the leftmost and the rightmost, I would create two variables left and right to iterate through all children and called isMirror helper method with the corresponding nodes. If we find any non-mirrored image, we return false immediately. At the end, if the number of roots children is odd, which can be checked by comparing the left and right variables, they will have the exact same value when the children size is odd. I just need to do a final call to isTreeMirror, the same method that we're dealing with right now, with the middle child node, so iterating the same algorithm with the middle node. If this is true, then return true. If the number of children is not odd, then we simply return true in this case.